In the year 2000, a total of about 50,000 asteroids were known. Currently, in the year 2023, there are about 1.2 million asteroids found in the solar system. That is an increase of about 24 times compared to the year 2000. The Vera Rubin Observatory is a giant telescope. It has a massive mirror. It is about 8.5 meters in diameter. In 2024, or a bit beyond, this telescope is expected to be finally active. And because this giant telescope is going to be photographing the entire available sky every few nights, it is expected over the course of 10 years for it to discover a few million more asteroids. Basically, this telescope alone is going to surpass the current number of asteroids discovered by a few times. Just maybe, this telescope will get to find the planet 9, for which there are strong indications. Now, with so many asteroids even currently found, 1.2 million, quite a few of them are quite weird. For example, 10,199 Chariklo. This asteroid is located between Saturn and Uranus, so it's usually about 15 times further away from the Sun than the Earth. With a diameter of about 250 kilometers, it is pretty large for an asteroid, but its most peculiar feature are its rings. On June of 2013, it passed in front of a star, which is called the occultation, and 13 massive telescopes were observing the occultation. What was found was a dimming pattern consistent only with rings. And on top of that, there are two of them. They are separated by around 10 kilometers. The inner ring is about 6.5 kilometers wide, while the outer one is 3.5 kilometers wide. In October of 2022, the near-infrared camera on NASA's James Webb Telescope was used to watch the occultation of Chariklo in front of a star. But this wasn't a full occultation. Rather, only the rings of Chariklo managed to be in front of a star. And what resulted again was a dimming pattern consistent only with rings. The brightness graph of the occultation clearly shows it again. This is the first known asteroid with confirmed rings. The rings likely have at least some water ice as well in their composition. Between 1997 and 2008, water ice indications in the spectrum of Chariklo were largely not present. But after 2008, Chariklo brightened, and suddenly water ice indications were clearly present in its spectrum. The most likely reason for this is, again, rings. Between 1997 and 2008, the rings of Chariklo were facing us sideways from the point of view of the Earth. Thus, that led to a lower surface area viewed of the rings and a lower brightness level, which explains why it was dimmer back then. The lower surface area viewed also explains why the spectrum was lacking in water ice indications, because a smaller surface area viewed of icy rings leads to a spectrum that is not as rich in indications of water ice. Right now, since the rings of Chariklo are facing us in a way more tilted way, the surface area viewed is greater, so the water ice spectrum is clearly present. And the brightness levels are much greater compared to when the rings were facing us sideways. The origin of these rings is not entirely certain, but there are indications that they formed when a relatively slow impact occurred, causing debris particles to be ejected and subsequently captured into orbit. The age of these rings is also largely unknown, and the estimates vary wildly. How long they are going to be sustained going forward is also largely unknown. Next, let's look at 130 Elektra, an asteroid with 3 moons. This is the most amount of moons for a single asteroid that is currently known. They are also all sort of unnamed. That is to say, they don't have a name with just letters. Now, Elektra itself is about 200 kilometers in diameter. That is large for an asteroid. However, its moons are tiny compared to it. The smallest one is only about 1.6 kilometers in diameter. It is also the closest moon to Elektra, at a distance of only about 350 kilometers. It also needs only about 16 hours to complete the entire orbit around Elektra. The middle-sized moon is about 2 kilometers in diameter, and it is also the second closest one to Elektra, at about 500 kilometers. This satellite needs 28 hours to complete the entire orbit around Elektra. And the largest moon is about 6 kilometers in diameter. It orbits Elektra at a distance of 1,300 kilometers, and it needs 5 days to complete an orbit around Elektra. Now, it was determined that the middle-sized and the largest moon have a spectrum that is similar to Elektra, which suggests a similar composition to Elektra, which also then suggests that these two moons are fragments of Elektra that went into orbit when some object hit Elektra, which caused it to send pieces of its surface flying into space. Now, although Elektra was found in 1873, all of these moons were found after the year 2000. Elektra itself is an asteroid in the asteroid belt, a region in the solar system relatively densely packed with asteroids. It is located between Mars and Jupiter. The belt is about 3 times further away from the Sun compared to Earth, so the temperatures there are very approximately around minus 100 degrees Celsius on objects that are there. Although there is quite a lot of variation in temperature there, it's pretty much at all times more than enough for water to be completely frozen. Now, in total, there are about 14 relatively well-documented asteroids with more than one satellite. Of those, the one with the largest moons is called Lempo. This asteroid is about 270 kilometers in diameter. However, its moons are also relatively massive. The largest moon is called Hissi, with a diameter of about 250 kilometers. It is so large that it's at a point where it's hard to even call it a moon, as they are both so similar in size. And also Hissi and Lempo are orbiting a point that is outside of themselves. They are also about 1,000 kilometers away from each other. Now, the third satellite is significantly smaller than the two mentioned objects. That satellite is called Psyche, and it is 130 kilometers in diameter. Also, compared to Hissi and Lempo, which are both very close to each other, Psyche, on the other hand, is orbiting them at a distance of 7,400 kilometers. How this weird system formed is still not certain. This system, with 3 objects where Lempo is the largest, is in the region of the solar system called the Kuiper Belt, which is beyond Neptune. In the Kuiper Belt, there is also Pluto, Eris, Haumea, and other dwarf planets. Lempo is orbiting the Sun usually at a distance that is about 40 times further away from the Sun than the Earth, although its distance from the Sun varies quite a bit, as its orbit is not circular and it's not centered on the Sun. Although Lempo, the largest object in this system, is indeed large for an asteroid at 270 kilometers in diameter, the Moon still has a diameter that is about 13 times longer. Now, that was, relatively speaking, a massive asteroid system. However, what about the opposite? What about a tiny asteroid system? For that we have 1994 CC. As the name suggests, the asteroid was found in 1994. In the year 2009, this asteroid was only about 2.5 million kilometers away from the Earth. For some perspective, the distance of the Moon from Earth is about 385,000 kilometers. So 1994 CC was 6.5 times further away from the Earth than the Moon. In terms of how generally distant asteroids are from Earth, this is exceptionally close. And that close distance also allowed in 2009 for these images to be captured with radar imaging. And this asteroid is also tiny. It is about 650 meters in diameter. And it also has two moons that are about 50 meters in diameter. So these two moons are about the size of just a regular residential building. The moon closest to 1994 CC is orbiting at a distance of 1.7 kilometers, and it completes the orbit around it in 1.2 days. While the second moon, the one that is more distant, is orbiting 1994 CC at a distance of 6.1 kilometers, and it completes the orbit around 1994 CC in 8 days. Now let's look at 2014 FA72, a very significant distant object. Based on how much it reflects light, the estimates are that it is around 250 kilometers in diameter, possibly quite a bit larger. To understand how distant this object is, I am going to use astronomical units. One astronomical unit is equal to the distance between the Sun and the Earth. Now, at the moment, 2014 FA72 is about 65 astronomical units away from the Sun. But based on the 4-year observation of the object's movements, we know that at its closest point in orbit, it should be about 36 astronomical units away from the Sun, so around the distance of Neptune. But at its farthest from the Sun, it is about 3,300 astronomical units away from the Sun, which is about 500 billion kilometers away from it. That is 19 light days away from the Sun. So at its most distant orbital point, from FA72, the Sun appears 19 days in the past. FA72 is also, because of that, receiving many millions of times less sunlight there than the Earth is. Going at a speed of about 10 kilometers a second, which is 10 times faster than a shot bullet, then you would need about 1,500 years to reach FA72 at that distance. 2014 FA72 also needs 60,000 years to complete an orbit. Considering how faint objects can get after they get past a certain point in the solar system, that would mean that many dwarf planets are likely lurking out there, maybe even whole planets, that are so dark and so far away that we cannot spot them. In 1991, NASA's Galileo spacecraft, that was on a mission to reach Jupiter, also managed to visit the asteroid called 951 Gaspra. This is the first asteroid that was imaged up close. The asteroid is 18 kilometers long at its longest, and is pretty typical overall. In August 1993, nearly 2 years after its visit to Gaspra, the Galileo spacecraft also visited another asteroid called 243 Ida. At its longest, this asteroid has a diameter of 60 kilometers. This amazing shot was taken at a distance of 2,400 kilometers away from Ida. It revealed a heavily cratered surface. It is so saturated with craters that, as the new ones are forming, they are erasing the previous ones. Also, the surface of Ida is covered with a layer of regolith about 100 meters thick. Regolith is a loose material, and that material covers the solid rock of Ida. The initial visit to Ida happened in August of 1993, but nearly half a year later, in 1994, a new discovery was made from the flyby. Upon examination of the images that the Galileo spacecraft captured, it was found that the spacecraft also captured an image of Ida's moon, called Dactyl, which was at the time about 90 kilometers away from Ida. This is the first asteroid moon to be imaged up close. The images revealed that Dactyl is also cratered. Surprisingly, one crater also has a central peak. And it's also surprising that this tiny moon, which is only about 1.5 kilometers in diameter, is also somewhat spherical. The next time that a moon asteroid was imaged up close happened 29 years later on September of 2022. I am talking about NASA's DART spacecraft that captured this image of a moon called Dimorphos. It is only about 150 meters in diameter, and it is orbiting an asteroid called Didymos that is 750 meters in diameter. Also, the DART spacecraft collided with the Dimorphos moon, which also managed to change the orbit of Dimorphos around Didymos, going from 11 hours and 55 minutes down to 11 hours and 22 minutes. The dust tail that was produced after the impact was around 10,000 kilometers long, nearly the diameter of Earth. The impact was so powerful that it likely caused a global resurfacing event on Dimorphos. A future mission is planned to Dimorphos in order to observe the changes. Overall, this mission showed that redirecting asteroids of a certain size is possible. Next, let's look at 253 Mathilde, an asteroid in the asteroid belt. It reflects about 4% of the light that hits its surface because of its carbon content. At its longest, it has a diameter of 66 kilometers. It is also the third asteroid that was imaged up close. It was imaged by NASA's Shoemaker spacecraft in 1997. Also, the Shoemaker spacecraft ended its mission in 2001 by landing on an asteroid called 433 Eros. Mathilde is clearly characterized by its enormous craters that heavily contort its surface. It has a few of them. Two of the largest ones are close to the diameter of Mathilde itself. This asteroid completes a rotation around itself in 17 days and 9 hours. That is one of the slowest rotation periods known for an asteroid. Usually, asteroids complete a rotation in 2 to 24 hours. Next, let's look at 490 Veritas, an asteroid in the mentioned asteroid belt. It is about 110 kilometers in diameter. Most planets and an enormous amount of large asteroids show indications that they formed billions of years ago, and a lot of them formed shortly after the Sun did 4.5 billion years ago. However, the indications, which include the orbit regarding 490 Veritas, suggest that it formed 8.3 million years ago through a very powerful collision. A formation age of 8.3 million years is very young for a significant object in the solar system. A later study also confirmed an exceptional increase of interplanetary dust deposit in seafloor sediment 8.2 million years ago. The likely reason that the Earth experienced this cosmic dust shower 8.2 million years ago was very likely because of a collision that formed 490 Veritas 8.3 million years ago. The dust that was created through the powerful collision traveled to Earth with the help of solar winds. Next we have 16 Psyche, another asteroid in the asteroid belt. With a mean diameter of 220 kilometers, it is the largest and also the most massive metallic asteroid. Through radar, it was determined that its surface is rich in metals, but some regions are much more metallic than others. Its density of about 4 grams per centimeters cubic is very high for an asteroid, and it's also what indicates that this entire asteroid in bulk is very rich in metals. There is also a mission planned to this asteroid. NASA is planning to send the spacecraft called Psyche, the same name as the asteroid. It is set to launch on October 10th, 2023. If it launches then, it should reach the asteroid in 2029. However, it's also quite possible that the launch will be postponed. Next, let's look at Oumuamua, found in 2017. It is very likely that this object came from outside of the solar system. Its odd motion of movement, great speed compared to the other objects in the solar system, and trajectory all point towards the fact that it is of extrasolar origin. Its path and speed is such that it cannot be captured by the Sun and put into orbit. Thus, it will eventually leave the solar system. Its age is also unknown. It could be older than the solar system. Also, its origins are unknown as well. We don't know from what star that it originates from. Its shape is very elongated, and it is in the area of being around 1 kilometer long. Next, let's look at 2014 RC. It passed the Earth at a distance of 40,000 kilometers, which is nearly 10 times closer to the Earth than the Moon is. It is between 12 and 25 meters in diameter, and measurements by multiple telescopes show that it completes a rotation around itself every 16 seconds. That is incredibly fast. It is one of the fastest, if not the fastest, recorded rotator. Next, let's look at Arrokoth. It was visited by the NASA's New Horizons probe after its visit to Pluto. So, this asteroid is in the Kuiper belt. It's about 44 times further away from the Sun than the Earth. Its length, at its longest, is 35 kilometers. What is odd about this asteroid is that it clearly looks like 2 asteroids glued together. And what likely happened here is that 2 objects collided relatively slowly, such that they formed into a single asteroid with a neck. That neck also indicates that the density of this object is very low, likely lower in density than even water, meaning that the matter in the object is not tightly packed together. Arrokoth is also quite red. Usually the red-brownish coloration on a celestial object indicates the presence of organic compounds. In the case of Arrokoth, what we are likely looking at is tholins, which are organic compounds that form under solar radiation. Now let's look at Bennu, an asteroid that approaches the Earth within a distance of 400,000 kilometers, so about the distance of the Moon to Earth. This asteroid has a diameter of 490 meters, so its diameter is the height of some of the tallest buildings on Earth. Every 4.3 hours, it completes a rotation around itself. Possibly that fast rotation is why Bennu has a ridge. Bennu is a Type C asteroid. Type C asteroids have lots of carbon. Type C asteroids are also the most common type of asteroid. So, although it isn't exactly weird because of that, it certainly did defy expectations in a few significant ways. When NASA's spacecraft called OSIRIS-REx reached Bennu in 2018, it revealed a surface that, surprisingly, is filled with massive amounts of rocks. There are many huge boulders on its surface. more than 200 of them are larger than 10 meters. But the material that Bennu is made up of is loosely held together. When OSIRIS-REx went in up close for a sample of Bennu, upon a gentle contact, the surface went everywhere. If OSIRIS-REx had not fired its thrusters to back away, it would have possibly sunk into Bennu. Next, let's look at 4 Vesta, the largest known asteroid by diameter in the solar system. It is located in the asteroid belt. At its longest, it is 570 kilometers in diameter. Now, Ceres, also in the asteroid belt, is indeed much larger at 950 kilometers. But it is not an asteroid, although it is frequently mistakenly mentioned as being an asteroid. It's large and massive enough to have gravity that causes it to be clearly round, so it's a dwarf planet. If we considered Ceres to be an asteroid, then Pluto, which is another dwarf planet, would also have to be classified as an asteroid, Eris as well, and pretty much every single other dwarf planet. That would make things confusing. 4 Vesta has about 10% the mass of the entire asteroid belt. In this image, you're looking at Mathilde, Ida, Eros, and Gaspra. All of these asteroids were already talked about in this video, and they are all tiny in comparison to 4 Vesta. Vesta was visited by NASA's Dawn spacecraft in 2011. After that, it set its course towards Ceres. Vesta completes a rotation around itself every 5 hours. It has a density of 3.5 grams per centimeter cubic. That is pretty dense for an asteroid. Vesta is also differentiated, meaning that it has different materials separated into different layers. It has a metallic core of about 200 kilometers in diameter. Above that, it has an olivine mantle, and above that is a relatively thin crust. Vesta is packed with craters. For example, let's look at the snowman craters. The largest one in this image, at the bottom, is about 63 kilometers in diameter. But by far the largest crater on Vesta is the Rhea Silvia Basin. With a diameter of 500 kilometers, it's nearly matching the diameter of Vesta itself. At the center of this enormous crater is a 200-kilometer wide peak that rises about 20 kilometers above the floor of the crater. It is an extremely tall mountain, basically around 3 times the height of Mount Everest. However, that mountain is on an asteroid, and asteroids are nearly always disfigured. So judging what is a mountain and what is not on an asteroid is hard. Still, the Rhea Silvia peak is enormous. The impact that created this crater was so great that many lines concentric to Rhea Silvia formed, and quite far away from Rhea Silvia. The largest one is the equatorial Divalia Fossa. It is about 5 kilometers deep, 10 kilometers wide, and 465 kilometers long. Its length is close to the diameter of Vesta. And those were some of the weirdest asteroids in the solar system. Obviously, there are probably some out there that we don't know about, because we haven't found them. But with the Vera Rubin Observatory, likely quite a few weird asteroids are going to be revealed, considering how many asteroids it is expected to discover. So that is something exciting to look forward to. Another exciting asteroid-related thing is Psyche, the orbiter mission that should be in action around 16 Psyche, the asteroid, in the near future.